Hello everybody. For this section, we're going to be talking about surface water in a little bit more detail. So, what are we talking about when we say surface water? We mean lakes, places like swamps, and streams. And we'll cover this a little bit, but for the most part, one of these that is geologically the most interesting and the most active are the streams. Lakes and swamps, I think of in many ways as being the products of geologic forces. Something like these lakes here, our Great Lakes, are a result of carving by glaciers, as opposed to streams, which are actually shaping the environment they're in, shaping the ground and moving and changing things on the surface. So primarily we're going to be talking about streams for this section here. Stream is any body of water that flows downslope along a clearly defined natural passageway, so through a channel. These shape the Earth's surface, whereas lakes and swamps are more of a byproduct of the Earth being shaped by some other force, some other driver. And types of streams, we're going to cover rivers, biggest, creeks, which are somewhere in the middle, and brooks, which are the very smallest. And the best way to think about this, the way that I like, a river is so large that you not only can you not jump across it or step across it, but you couldn't even throw something from one side to the other. If you've ever been to somewhere like the Mississippi River, you know that this is really quite a bit bigger than it looks. You couldn't throw something to the other side, you couldn't step to the other side. Now, a creek, it's a little bit more than you could jump over from one side to the other, but you could pretty easily take a rock and throw it to the other side of the creek. And finally, for a brook, let's move me out of the way. A brook is small enough that not only could you throw something to the other side, but you could very easily jump over or even step over to the other side of the brook, being the smallest of our three here. Now, we talk about our stream channels where the water flows through. These are clearly defined passageways where the stream flows. We're going to talk about a couple different types, which you can see on the right here. Right, we have straight, braided, and meandering. So a straight channel, and this doesn't mean perfectly straight. You're never going to see a perfectly straight, not curved at all sort of river, but it is primarily straight, especially compared to the others that we're going to see in a bit. These tend to be in areas of high gradient, so steep slopes, as in mountainous areas towards the heads of streams, where the stream begins up at the mountain with a really high slope leads to a high gradient there. During common, we see rapidly moving water, high gradient, it's moving fast, high energy, as well as waterfalls, and they tend to carve out these V-shaped valleys or canyons. So now this actually is in Yellowstone here. You can see an example of this sort of V-shaped valley carved by a relatively straight river, not perfectly straight, but predominantly moving in one direction. You see this also, sort of V shape in Grand Canyon, right? Sort of V pattern to the relatively straight Colorado River as it carves through here. Now, you can also have braided streams. So you have these multiple strands of water moving, and each one is separated by these little things in the middle, right? These can be little bars or islands in the middle of the river, a little bit of alluvium, sort of unconsolidated, loose river sediment that is piled up here, and you have these little submerged bars, right? So like an island, but it's beneath the surface. It's not poking out up above the surface of the stream. These tend to be in places which are a little bit lower in gradient, where we have multiple smaller channels which split and then recombine and then split again. Typically, these are going to be in places where you have a lot of sediment inside of the stream. So your mountains or your glaciers where you have sediment which has been ripped off of surrounding rocks by the glacier, and then near the edge of the glacier is put into the glacial outwash stream, or near mountains where there tends to be a lot of weathering and erosion. That's sediment that's moving. These typically have a lot of sediment load, we'll talk about this more in a bit, which is contained within the river. So lots of little tiny rock particles and bits. So you can see these can sometimes be very, very complicated, right? Very, very different view from what we saw with the straight rivers. You have all these different little strands separated by the little bars and islands in between for both. Sometimes you have many, many different little strands of water moving through the braided stream. You can also have something called a meandering stream channel. So in this case, you have something which is a little bit lower in terms of gradient. It's meandering. It wanders. It doesn't go straight from point A to point B. It takes this sort of winding, looping path on the way there. So it's curving back and forth in a single channel, and this is characteristic of lowlands. So relatively flat places, far away from mountains or anywhere that's steeper or higher gradient, a little bit lower energy for these. These tend to move and meander over time, and they form wider floodplains, things called oxbow lakes, which we'll look at in a minute, and they tend to flood regularly. Many of the longer rivers of the world tend to be meandering rivers. We'll cover this a little bit more in a bit. So as an example, here we have this little oxbow lake. So actually, if you look over here on the other one, you might imagine that water keeps flowing here through many, many years, and eventually it cuts through this bit of land entirely right here, to where this is completely gone. The river is no longer going to take this path all the way around here. It's just going to flow straight down and through like this. And what's going to happen to this carved out area, the depression over here? Well, it's going to be filled with rainwater, but it's not going to be connected to the rest of the river. And that is what happened over here with the little Oxbow Lake. It's been a cut off meander of the river. So floodplains, what are we talking about here? So there's this large, flat, or mostly flat area which is adjacent to the stream, which tends to experience occasional floodings. Imagine a really, really severe precipitation event, a big rainstorm. It completely floods the river, and it covers this whole flat area, everything in the entire floodplain. This is going to be everything from the banks of the stream channel all the way to the banks of enclosing valley walls or steeper walls. The whole thing which floods here is the floodplain. And the soils here are typically very, very rich, good for agriculture. Nice mix of clay, silts, and sands. Great farming soil. What are the variables for our stream channels? Well, the first one that you need to know is that the first two numbers in the access code are 20. So our primary variables here are going to be the gradient. So how steep is the stream channel? Are we in the mountains? Are we in a lowland far away from the mountains? What is the amount of energy we're putting into the stream here? What is the amount of discharge? So how much water moves through the river in total, as well as our load. So this is sediment load. How many little pieces of rock and dirt and other things are there that are moving through the river? And we break this into a couple parts. We have the bed load, so largest sediments, the most dense stuff is going to sink all the way to the bottom, the bed of the river where it moves along. You have a suspended load, so the smaller particles aren't really going to sink all the way down. Instead, they're going to be moved somewhere in the middle of the river. Not at the bottom, not necessarily at the top, but somewhere suspended in the middle, being pushed by the river. And you would also have a dissolved load here. So there are all these little chemical pieces which have been dissolved into the water, little ions and molecules in solution being dissolved into the water and then carried chemically, not as little physical pieces. So just as a little chart sort of summarizes, puts it all in one place, straight rivers are going to be high energy, lower discharge, typically a little bit smaller streams and lower load. Meandering rivers are going to have lower gradient, a lot of discharge, and a very, very high suspended load in them. And braided rivers are going to be lower gradient, very much a variable amount of discharge, total amount of water moving through, and a high bed load sediment, the big stuff that's at the bottom and which builds up to form the little islands and the bars. So what are our stages of stream development? We like to divide streams into either being very, very young, being more mature, or even old. The younger streams tend to be high energy, as you would imagine. These are going to form our V-shaped valleys, tend to move very, very quickly, less in the way of floodplains, very, very related to our geometry here of a V-shaped valley. Very, very difficult to flood. Tend to contain things like rapids and waterfalls. High energy, lots of movement here. Our more mature streams tend to be more moderate in terms of the gradient, in terms of how fast they move. They might carve out an entire valley floor as opposed to a more V-shape, a strict, sharp V-shaped valley. There is some periodic flooding with these, and typically a small, not extensive floodplain. And finally, you can have an old river. So low energy, low gradient and velocity, deposits a lot of material as it erodes, tends to meander greatly. This will happen. Tends to be a much wider river as opposed to the strict, sort of sharp V shape, and you have these wide, well-developed floodplains along with oxbow lakes because there's been sufficient time for previous meanders to have been cut off here. And this diagram sort of gives a visual to what we're talking about here. Our youthful stream tends to be narrow, V-shaped walls, very, very high energy cutting in. More mature stream with a bit of a floodplain, but not a huge one here, somewhere in the middle between our two end members, youthful and old, where we have oxbow lakes showing the history of the river where different meanders have been cut off over time, and a wide, extensive floodplain. So looking at it from the side here, our side view of it, we have a V-shaped canyon or more youthful river. So this is a more mature river which has a broad sort of entire river valley which contains both the channel itself as well as the floodplains, all the way up until we get to the point where the flood never reaches there up above the valley walls. So this all sort of begs the question, where does the original water come from? What is the original source of the water? By and large, we're going to have two answers for this. We can either have melted solid water, melting glaciers or ice caps, and also have precipitation. Those are going to be our two original sources of the water, which turns into these streams and channels and powers all of this. We divide larger regions, whole continents of the world into these drainage basins, depending on where we are. So all the precipitation inside of the red area here on the map, all of it ends up in the same place, right? All of the rivers and everything here collect water and channel it into the Gulf of Mexico. Similarly, everything in the green area over here, all the water which falls in that area, all the precipitation which falls there, one way or another, eventually over time makes its way into the Atlantic Ocean. So these drainage basins are the total area which all flows into the stream and eventually to the big reservoirs, which are our oceans and Gulf of Mexico. So we divide things this way, usually on the basis of topographic highs, some sort of mountain, some feature which serves to divide water. All the rain which falls on this side of the mountain eventually falls down into the Atlantic Ocean. All the water which falls on this side of the mountain range eventually comes to the Pacific, just as a very, very simple example here. When we look at the United States, all this, which is flowing into the Mississippi River and eventually into the Gulf of Mexico here, part of the reason why the Mississippi River is so large. And us, here in Arizona, everything which falls in the entire state, one way or another, eventually makes its way into the Colorado River, into the Gulf of California. And here we have our Great Divide in the middle, separating the Atlantic, broadly speaking, Atlantic region from the Pacific region in terms of rainfall. So this gives us an overview of all of our rivers in Arizona. Keep in mind that all of these, one way or another, find their way to the Colorado River. And I've included here just a list of our 10 longest rivers in Arizona. The numbers in parentheses are where they would be for the United States. It can help sometimes just to get a visual: Colorado River, Gila River, the Colorado Salt River, Santa Cruz River, Verde River, Puerto River, Virgin River, San Francisco River, and San Pedro River, finally. Next section, we're going to talk about stream landforms. See you then.